In the last section, we started looking at the fact that sometimes if we have the conjugate acid or the conjugate base in a salt form, it'll affect our pH. So example 12 shows us that I've got a 0.5 molar solution of Na2C2H3O2. This is the conjugate base of acetic acid. So they give me the Ka of acetic acid. Okay, so here's the way it works. I've got my sodium acetate. When it dissolves in water, it breaks into sodium and acetate. I don't care about sodium, it won't affect the pH. However, the acetate ion in solution reacts with water. It can pick up the H to form acetic acid and make an OH ion as well. They give me the Ka for this, but I don't have an acid losing an H. I have a base picking up an H. So I don't want Ka. If you remember, Ka times Kb equals Kw. Okay? They tell me that Ka is 5.5 times 10 to the negative 10th. I don't know Kb. Kw is a constant. It's always 1.0 times 10 to the negative 14th. So if I solve for Kb, Kb is going to be equal to 1.8 times 10 to the negative 5th. Well, if I look at this reaction, I know initially that I had 0.50 of this. I don't know how much of this I have. I don't know how much of that I have. I make the assumption that this is going to change a very small amount compared. So x squared over 0.50. My products times each other over my reactants. I ignore water because it's a liquid. So I'm going to solve for x. I multiply both sides by 0.50. Then I take the square root. X is going to be equal to 0.0030. Well, here's the problem. This is the concentration of acetic acid and the concentration of OH. So I can't solve for pH yet, but I can solve for POH. Remember, POH is equal to the negative log of the OH concentration. So my POH is going to be 2.52. To solve for pH, pH is 14 minus POH. So my pH is 11.48. Now, when you do these calculations, if I had said that this was my pH, because I wasn't really paying attention and I said, oh, I solved for X, I've got my concentration and moved on, I should logically be able to stop myself and say, wait, this can't be right. I'm adding something that makes the solution basic, so my pH needs to be greater than 7. The fact that this number isn't greater than 7 tells me that I'm not done with the calculation. It can't be the pH because it doesn't make sense. So always make sure you're checking that you know what you're solving for and that you're not confusing variables. Okay? So take a second and solve number 13. Number 13, you have sodium fluoride dissolving in water, and they give you the Ka for hydrofluoric acid. Okay? Now, we said that we can determine if a solution will be acidic or basic or neutral based on the ions it contains. So if I've got a salt, and my salt has the cation from a strong base, sodium, potassium, lithium, it is not going to affect the pH. If the negative ion is from a strong acid, hydrochloric, hydrobromic, hydroiodic, it won't affect the pH, since neither the cation or the anion affects the pH. My solution will be neutral. Okay? If I have the cation from the strong base, it will not affect the pH. So in this case, Na is from a strong base, will not affect it. K is from a strong base, will not affect it. Na is from a strong base, will not affect it. However, if the anion is from a weak acid, this is from acetic acid, hydrocyanic acid, hydrofluoric acid, these are capable of forming the initial acid, so each of these will act as a base. Okay? If I have the conjugate acid of a weak base, so here NH4 is the conjugate of NH3. This will affect the pH. However, Cl and NO3, hydrochloric and nitric, are strong acids. Weak acid, my solution's acidic. If both can affect the pH, it's going to get tricky. Okay? If both can affect the pH, then I actually have to look at Ka and Kb values. If the value of my acid is bigger than the value of my base, my solution is acidic. If the value of my base is bigger than the value of my acid, then it's basic. If the values are the same, then it's neutral. So here's the way it works. NH4C2H3O2. I know that NH4 plus is a weak acid. I know that acetate is a weak base. I don't know whether my solution will be acidic or basic or neutral yet. So I have to look up the Ka values. So this is table 14.2 from earlier in our notes. Okay? So I have NH4 plus. NH4 plus has a Ka value of 5.6 times 10 to the negative 10th. Okay. Now acetate, if I look at my table, these are only Ka values. So I've got acetic acid, but I don't have the acetate ion. It gave me the Ka value. I know that Ka times Kb equals Kw. Kw is a constant. So if I take Kw, divide by Ka, then I can determine the Kb value. My Kb value is going to be, 5.6 times 10 to the negative 10th. Well, the Ka for my acid is equal to the Kb for my base. Since these two numbers are the same, my solution is neutral. So take a second, use table 14.2, NH4 plus, you know the Ka value. HCN is my conjugate acid. They give me my Ka. Determine your Kb, and then figure out whether this solution will be acidic, basic, or neutral.